Ivana Cry smashed her thumb with a hammer while working on her roof. She got mad and threw the hammer horizontally off the roof from a height of 6.3 meters. All right, I'm going to stop right there. Horizontally is a key, and the height is 6.3 meters. All right, hit the ground 44 meters away, so another piece of information for us. All right, this amazed Ivana, so she calculated the speed at which she threw the hammer and found it to be. So we're looking for the speed. And since this is a horizontal launch, we have to split this up into X and Y components. And we're gonna look at the horizontal motion and the vertical motion independently. All right, so let's start filling in some of this information. All right, the first one, let's go height of 6.3 meters. Well, that is a vertical distance, so dy, 6.3 meters. We've got 44 meters away, and we're going to interpret that as a dx. So dx is 44 meters. All right, and being that she threw it horizontally off of the roof, and we're trying to find the speed, that is the horizontal speed is what we're looking for. All right, and we don't have to put final or initial here because we know that that is a constant in the extraction. So that should be pretty easy. All we need to do is use our speed, our constant speed equation. So we just need time, but there is no time anywhere in the question. So the amount of time it's in the air is purely determined by the height that it was launched from. All right, so let's go jump over to the vertical side here for a minute. A couple things about the vertical motion. We know that the initial vertical speed is 0, starts out at 0 and then begins to accelerate downward. And the rate of acceleration is acceleration due to gravity. I will use 10. I know some people will use 9.8, but I'm going to go with 10 for this. All right, so from here, we are looking to find the time. Uh-oh, my pencil lead. There we go. Okay, that's probably going to break also. Okay, so to find the time, we're going to use the second kinematic equation, and we're going to use it and put all the subscripts of y down here like this. I don't know if you can see that. Okay, and we know that the initial speed was 0, so that whole term goes to 0. And we're going to replace ay with g. So now we've got that dy equals 1/2 times gt squared. All right, and I will rearrange that. I'll multiply by 2 on both sides, divide by the g. Oh, that's great. And then take the square root to get rid of the squared. So I'll do that all at once. We'll say t equals twice the distance, and then divide it by g, and then take the square root. All right, so now I'll substitute in 6.3 times 2 divided by 10. So if the inside here of the square root is, I believe it was 1.29 or 1.26 or something like that. But don't forget to take the square root, and then what that takes you to is, if you use 10, you end up with 1.12. If you use 9.8, I believe that you get 1.13 if you use 9.8. Okay, so now we have a time that it's in the air, and we can use this time over here because there's no difference between the time for vertical and horizontal. So let's just substitute that in. 44 for our height, or I'm sorry, for our horizontal distance. And then the time, I'm going to go with the 1.12 because that was the first one I had. And that works out to be, I think it was 39 and a whole bunch of change over here. So I'll leave that off and we'll just call it 39 because we've got 2 sig figs here, 2 sig figs there, so my answer should be 2 sig figs. So I end up with 39 meters per second as the launch speed. So that's it as far as the quiz goes. There is one little bit, one extra little bit over here. So sketch the path of the hammer for a star. All right, so let's do that. So we're launching horizontally right here. So the hammer is just going to kind of follow this parabolic arc, and there we'll put the ground right there.